Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, I am Madam Maisara. Today I would like to explain about Chapter 5 Function and Graph. Subchapter 5.4 Exponential and Logarithmic Functions. This is Lecture 4, Part 1. Learning Outcomes. At the end of the lesson, students are able to A. Find the relationship of exponential and logarithmic functions by algebraic and graphical approaches. B. State the domain and range of exponential and logarithmic functions. What is exponential function? Exponential function is f(x) equals to a to the power of x, where x is element of real number, a is more than 0, and a does not equal to 1. Constant a is known as the base, and variable x is known as the exponent. Basic exponential function. There are two basic exponential function, which a f(x) equals to a to the power of x for a more than 1. B f(x) equals to a to the power of x for a in between 0 and 1. Let's look at for basic exponential function. For the first one, f(x) equals to a power x for a more than 1. Basic properties are, the first one, f(x) is more than 0. The second one, when x equals to 0, f(x) is equals to 1. So this is actually y-intercept. Then the third one, when x approach positive infinity, then f(x) is approaching positive infinity. You can see when x approach positive infinity, x is on positive side, then y is moving up to the positive infinity of y. Then the fourth one, when x approach negative infinity, f(x) is approach 0. The domain of this function is negative infinity, infinity. So this is the graph of f(x) equals to a power x for a more than 1. So y-intercept is 1. And then you can see on the right side, on the positive side of x, when x approach positive infinity, then y is also approaching positive infinity. And when x is approaching negative infinity, then the y is approaching y equals to 0, which is x-axis. It just approaching x-axis, but it cannot be touched x-axis. For the second basic exponential function, f(x) equals to a power x for a in between 0 and 1. Basic properties are, the first one, f(x) is more than 0. The second one, when x is approached 0, f(x) equals to 1. This is actually y-intercept. Then the third one, when x approach positive infinity, then f(x) is approach 0. When x is approach negative infinity, f(x) is approaching positive infinity. So the domain of this function is negative infinity, infinity. So then, this is the graph of f(x) equals to a power x for a is more than 0, less than 1. You can see y-intercept is 1. And when x is approaching positive infinity, on the positive side of x, you can see f(x) is approaching 0. It's just approaching x-axis, but it cannot be touched x-axis. Then, when x is approaching negative infinity, on the left side of x, you can see f(x) is moving up to positive infinity of y. Of example 1, sketch the following graph and find the domain and range. For question A, the function is f(x) equals to e power x. B, f(x) equals to e power negative x. And then C, f(x) equals to negative e power x. and then D, fx equals to negative e power negative x, and then E, fx equals to e power x plus 1, F, fx equals to e power x minus 1, G, fx equals to e power x plus 2, and lastly H, fx equals to 1 plus e power x minus 1. Let's look at for solution equation A, fx equals to e power x. So since A is equal to E, and E can be calculated by calculator, and which is the value of E is around 2.7 something. So then A is more than 1. So this type of fx is fx equals to a power x for A more than 1. So then we find y-intercept. To find y-intercept, we substitute x equals to 0 into fx and become e power 0, which is equal to 1. So then we get y-intercept is 1. So then we plot on the graph, we draw x-axis, y-axis, and then we plot y-intercept 1. Then when x approach positive infinity, we get e power positive infinity, which is fx is approaching positive infinity. Then we plot on the positive side of x, y is moving up to positive infinity, is around here. Then when x is approaching negative infinity, e power negative infinity, then fx is approaching 0. So we plot on the left side of x, y is near to x-axis. Then we connect these 3x, we get the graph of fx equal to e power x. So this is the graph of e power x. From this graph, we notice that the domain of f is negative infinity, infinity, which this graph can be moving to the left side and moving to, we can extend on the left and on the right. Then range of f is open 0. From below of this graph is open 0, y, and then positive infinity. So the range of f is 0, open, infinity. Let's look at for solution B, fn equals to e power negative x. Since a equals to e power negative 1, so e power negative 1 can be calculated by calculator, and the value e power negative 1 is around 0.3 something. So then a is less than 1. Second one, we find y-intercept by substitute x equals to 0 into fx. So then we get y equals to 1. So y-intercept is 1. We plot y-intercept, y equals to 1. Then when x is approaching positive infinity, then it's become e power negative infinity, which is fx is approaching 0. So we plot near x-axis. Then when x is approaching positive negative infinity, then it's become e power negative infinity, then it become e positive infinity. So fx is approaching positive infinity. So then we plot, then we connect these 3x, we get the graph of fx equals to e power negative x. Then from this graph, we notice that the domain of f is negative infinity, infinity. And then the range of x is 0, open 0 to positive infinity. Let's look at for question C. fx equals to negative e power x. Negative is in front of ex means that the graph is reflecting below the x-axis. So we just draw e power x, the graph of e power x, then we reflect below the x-axis. So first we find y-intercept. We substitute into fx. By substitute x equal to 0, we get -1. So y-intercept is -1. So then we draw e power x. E power x is like this. This is e power x. The dotted curve is e power x. Then we reflect below x-axis. So the graph of fx equals to -e power x is below x-axis with y -1. So this is the graph of -e power x. From this graph, we notice that the domain is -infinity, infinity, but range is -infinity until 0. 0 is not including. Now let's look at for solution D. Fx equals to -e power -x. Negative is in front e power -x means that the graph is reflecting below the x-axis. So then the x-axis is become reflection line. So first we find y-intercept. We get y-intercept is equal to -1. Then we draw e power -x. The graph e power -x is similar to the graph on question B. So it's like this lah. Then we reflect below the x-axis. We get a graph of -e power -x with y-intercept -1. From this graph, we notice that the domain is -infinity, infinity. The range is -infinity. The below one is -infinity. And the top one is approaching 0. So 0, open. Let's look at for solution E. Fy equals to ex plus 1. Plus 1 here means that it has horizontal asymptote at y equals to 1. So then we find y-intercept by substituting x equals to 0. So fx equals to e power 0 plus 1, which equal to 2. So we have y-intercept y equals to 2. Then we plot y-intercept 2. When x is approaching positive infinity, so e power positive infinity plus 1, e power positive infinity is positive infinity plus 1, then fx is approaching positive infinity. So then we plot here. And then when x is approaching negative infinity, we get 0 plus 1. So fx is approaching 1. So then we plot when x is approaching negative infinity, we plot near approaching horizontal asymptote y equals to 1. So then we connect these 3 points. We get the graph would be like this. So this is the graph of fx equals to e power x plus 1. So from this graph, we notice that the domain is -infinity, infinity, and the range below is 1, is not including. So range of f is equal to 1, infinity. Let's look at for solution F. Fx equals to e power x minus 1. First, we find y-intercept by substituting x equals to 0. So then fx equals to e power 0 minus 1 equal to 0. So it has y-intercept y equals to 0. Then we plot y-intercept 0. Okay. Since e power x minus 1, -1 here is mean horizontal asymptote at y equals to -1. So then alternatively, we can sketch e power x first. Then, so e power x is dotted curve here with y-intercept 1. And then, we shift the graph until the y-intercept is 0. So we shift down the graph and it also has horizontal asymptote y equals to -1. So the graph is shift down until it has y-intercept 0. So from this graph, we notice that the domain is negative infinity, infinity. The range is -1, infinity. Let's look at for solution G. Fi equals to e power x plus 2. So first, we find y-intercept by substituting x equals to 0. So then we get Fi equals to e power 0 plus 2, which is e square is around 7.39. And then, when x is approaching positive infinity, the graph is Fi is approaching positive infinity. When x is approaching negative infinity, then Fi is approaching 0. So the graph will be like this. So from this graph, we notice that the domain is negative infinity, infinity, and the range is below open 0 to infinity. Let's look at for solution H. Fi equals to 1 plus e power x minus 1. First, we find y-intercept. We get Fi equals to 1 plus e power 0 minus 1, which equal to 1.3678. Alternatively, 1 plus e power x minus 1, 1 is actually horizontal asymptote at y equals to 1. And then, we draw e power x minus first, and it has y-intercept 0.3678. And then, we shift the graph until it has y-intercept 1.3678. Means that we're moving the graph up. It also has a horizontal asymptote at y equals to 1. And the graph will be like this. We can cancel out the graph. We can erase the dotted graph. From this graph, we notice that the domain is negative infinity, infinity, and the range is 1, infinity. What is logarithmic function? A logarithmic function is a function of the form Fi equals to log base a x, where x is more than 0 and a does not equal to 1. The constant a is known as the base, and the variable x is any positive real number. Basic logarithmic function a. Fi equals to log base a x, where x is element of positive real number, a is more than 1. B. Fi equals to log base a x, for x element of positive real number, a in between 0 and 1. The first basic logarithmic function a. Fi equals to log base b x, x element of real number, b is more than 1. Basic properties are, the first one, when x equals to 1, Fi equals to 0. This is actually x-intercept. The second one, when x is approaching 0, Fi is approaching negative infinity. The third one, when x is approaching positive infinity, Fi is approaching positive infinity. The range of f is equal to negative infinity, infinity. So, this is the graph of Fi log base b x with x-intercept 1. The second basic logarithmic function b. fx equals to log base bx. X is element real number, b in between 0 and 1. Basic properties are, the first one, when x equals to 1, fx equals to 0. This is x-intercept. The second one, when x is approaching 0, fx is approaching positive infinity. The third one, when x is approaching positive infinity, fx is approaching negative infinity. The range of f is negative infinity, infinity, and the graph is like this, with x-intercept 1. Example 2. Sketch the following graph and find the domain and range. A. Fx equals to ln x. B. Fx equals to negative ln x. C. Fx equals to ln negative x. And D. Fx equals to negative ln negative x. E. Fx equals to ln x minus 1. F. Fx equals to negative ln x plus 2. G. Fx equals to 2 plus ln x plus 1. And finally H. Fx equals to negative 2 ln 2 minus 3x. Let's look at for solution A. Fx equals to ln x. So ln x is log base e x. So since e has the value 2 point something, so then the base is more than 1. So if the base is more than 1, the graph is moving up. Then find domain of this function. Since ln x, which is log base ex, so x for x more than 0, so then the domain suppose 0 infinity. 0 infinity means that on the right side. And then we find x-intercept. We substitute with fx equals to 0. Then we get ln x equals to 0. So we e both sides. We get e power ln x equals to e power 0. So then x equals to e power 0, which is x equals to 1. So then we plot x-intercept 1. And then the domain here is on the right side. X more than 0. And since a is more than 1, is moving up. So the graph should be like this. The domain is 0 infinity. And the range is negative infinity, infinity. So logarithm, the range is always negative infinity, infinity. Let's continue with solution B. Fx equals to negative ln x. So first we find the domain. The domain is x more than 0. And then it has x-intercept at x equals to 1. Negative is in front. Logarithm means that it's moving down. So alternatively, we can draw ln x. It's similar to the graph in A, in equation A, and then we, since negative is in front, logarithm is moving down, so then the graph it will be like this, the pink curve. So the domain of this function is 0 infinity, and the range of this function is negative infinity, infinity. Let's look at for question C. Fx equals to ln negative x. So first we find domain. Negative x is more than 0. So then we get x less than 0. So the domain here is negative infinity 0, which is on the left side of x-axis. Then we find x-intercept. We get ln negative x equals to 0. So then in both sides we get negative x equals to e power 0. So then we get x-intercept is x equals to negative 1. Since in front of logarithm is positive, so then it's moving down. The graph is moving down. but we sketch the graph on the left side of x-axis with x-intercept -1. So the graph will be like this. From this graph, the domain is -∞, 0, and the range of f is -∞, ∞. Let's look at for question D, f(x) equals to negative ln negative x. Negative is in front logarithm, means that is moving down. The graph is moving down. So ln negative x, we can draw ln negative x. Since negative x is supposed the domain negative x is more than 0, so then we get x less than 0. So the domain is on the left side of positive. On the left side of x-axis. And then we draw ln negative x. Suppose this is ln negative x, the dotted curve here. And then negative ln negative x means that is moving down. So ln negative x is moving up. So it's become like this for negative ln negative x. So from this graph, we notice that the domain is -∞, 0, and the range is always -∞, ∞, for logarithm function. Let's look at for solution E. f(x) equals to ln x minus 1. So first, we find domain of this function. X minus 1 is more than 0. Then we get x more than 1. So the domain here is 1, ∞. And it also has vertical asymptote at x is equal to 1. Then we find x-intercept, we get ln x minus 1 equals to 0. And then e both sides, we get x minus 1 equals to e power 0. Then finally, we get x equals to 2 as the x-intercept. Since in front of logarithm is positive, so then it's moving up. So then the graph has vertical asymptote at x equals to 1, has x-intercept 2, and the graph is moving up. So the graph would be like this. The domain of this function is 1, ∞, and the range is -∞, ∞. For question F, f(x) equals to negative ln x plus 2. So first, we find the domain of this function. X plus 2 is more than 0, so x is more than -2. So the domain for this function is open -2 to ∞. Means that the vertical asymptote is at x is equal to -2. Then we find x-intercept, f(x) equals to 0. So then negative ln x plus 2 equals to 0. Then we positive both sides, ln x plus 2 equals to 0. Then e both sides, we get x plus 2 equals to e power 0. Then finally, we get x equals to -1. Since in front of logarithm, in front of ln has negative, so then it's moving down. The graph is on the right side with vertical asymptote at x equals to -2. And it's moving down. On the right side, it's moving down with x-intercept -1. So suppose like this, the pink one. So from this graph, the domain is -2 ∞, and the range is -∞, ∞. Let's look at for solution G. f(x) equals to 2 plus ln x plus 1. So first, we find domain of this function. X plus 1 is more than 0. Then we get x more than -1. So the domain here is -1 ∞. So then we have a vertical asymptote at x equal to -1. Then we find x-intercept, f(x) equals to 0. Then 2 plus ln x plus 1 equals to 0. Ln x plus 1 equals to -2. And then we e both side, we get x plus 1 equals to e power negative 2. And finally, we get x equals to negative 0.865. Since in front of logarithm is positive, so then the graph is moving up. So it has vertical asymptote at x equal to negative 1. It has x-intercept negative 0.65 and it's moving up. So this is the graph of fx equals to 2 plus ln x plus 1. From this graph, we have the domain negative 1 infinity and the range is negative infinity. Now let's look at for h. Fx equals to negative 2 ln 2 minus 3x. So first we find domain of this function, 2 minus 3x more than 0. So we solve this inequality until we get x less than 2 over 3. So the domain here is negative infinity, 2 over 3. Then we find x-intercept. We get x equals to 1 over 3 as the x-intercept. Then we plot. Since the domain is negative infinity 2 over 3, so means that the vertical asymptote is at x equals to 2 over 3. So then since in front of logarithm is negative, is moving down and has x-intercept 1 over 3. So the graph will be like this. The domain is negative infinity 2 over 3. The range is always negative infinity for logarithm. To be continued on part 2. Bye.